All right, 1-7, our last lesson in MT1, midpoints and bisectors. All right, we are going to learn about the point in a directed line segment that partitions it in a given ratio, specifically exactly in half. We're also going to learn about the word bisect. So a midpoint, I believe there is a fill in the blank on this one. Let me go find my notes that I'm following along with you. The midpoint of a segment is the point halfway between the endpoints of the segment. So you're going to fill in the word halfway and endpoints. Okay? So it's exactly in the middle. Exactly in the middle. Midpoint. Middle. All right? So if we go down to that next point on your notes, if AB has endpoints x1 and x2 on a number line, then the midpoint M has this coordinate where you add them together, x1 plus x2, all of that divided by 2. Now, you guys know this. What is this called when we add them together and then divide them by 2? That's called the average. We're averaging them together. We're finding the middle of those values. So midpoint is an average. It's an averaging of those numbers. Okay. So let's find the midpoints here. What's the midpoint of this number line? So if we have this number line and we've got -3 and 8, how do we find that? Well, what we're going to do, and I think this is already written out for you, is we are going to plug those in. This would be our x1. I think they even made this one over here x1, and they made this our x2. And we add 8 plus -3, divide by 2. Now, does it matter if we make this one x1 and that one x2? Could we make this x2 and this x1? Let's try it. -3 plus 8 divided by 2, that becomes 5 over 2, and that becomes 2.5. Same answer, yes. It doesn't matter which one is which. For midpoints, doesn't matter which one is which, okay? So there is no directionality for midpoint. You can't screw it up. That's what I'm trying to say, okay? Oh, and look at that. That was the very next question. Would it matter? It does not matter. That's a big no. Okay. So go ahead and do quick this math. What's the midpoint of segment AF? Pause me if you want. Hopefully you found that the midpoint is 1. 7 plus -5 is 2, divided by 2 is 1. Okay, let's try a real world problem. A pony works at a vintage clothing store. She wants to hang a new sign that is centered above the dressing room doors. Given that the dressing room doors have the same width, find the point along the wall that a pony should hang the new sign. And she measured from the wall to each of the sides of those doors. Okay? She measured that one side is 7.5 feet from the walls and the other side is 13.5 feet from the walls. And that would be then 7.5 plus 13.5, all divided by 2. And when you do that, you get 21 divided by 2, which is 10.5. So then if they go back with a measuring tape and measure out, let's see, get myself a nice thick one, 10.5, she can put a nail right there and hang her nice picture right above the door. Okay? Pretty cool way to do it, actually. You can do that. Probably you've never thought of doing it that way. What are some other ways you could have located the midpoint? Probably this way would never have occurred to you, because I would not have done it that way. What other ways do we do? I probably would have just gone straight up from here and hung it. Other ways, I would have counted this as 0, and I would have measured over to here. Because the difference between there is what, 7.5 to 13.5? How much bigger is that? That's 6 feet. So I would have done the midpoint of that. I would have done 0 plus 6 divided by 2 and found that it's 3, and I would have measured over 3 feet exactly and hung it up that way. So I would have found a midpoint that way. Okay, so go ahead and practice right there with a real world problem with Jorge. Pause me. Okay, and hopefully you found that Jorge stops at 50th Street. Okay, now in the coordinate plane, which is much more what we're going to be using midpoints for, and we're going to be using midpoints a lot in geometry. So don't just skip past this or think that this is easy and I don't need to worry about it, but we're going to be using this math a ton. We use it twice. We don't just do it for the M or for the X or for the Y. We use it for the X and the Y to find our midpoint. Oh, and they are using it as a ratio. That's silly. They showed it, because it is a ratio of 1 to 1, they're showing it, putting it back into that ratio segment that we did in 1/6. Here's that equation that we used for it. And because it's a 1 to 1, everything's getting multiplied by 1 on top and they're getting added on the bottom. We end up with this equation for midpoints. So that is our midpoint formula when it comes to doing that in the coordinate plane. So there is your equation. You've got that in your notes right there in front of you. So midpoint formula in the coordinate plane. Note, it's the same thing we just did. It's the average, but we're doing it twice. One for X, one for Y. So let's try it. If we want to find the coordinates of the midpoint of AB, where A is at -2, 1, and B is at 8, 3, and we don't even draw it here. You can if you want. Go ahead and, oh, they didn't even, -2 and 1. So there it is. And B would be at 1, 2, 3, 4, 5, 6, 7, 8, and 2. 3, so it's going to be up here, 3, and you have to connect them. Where's our midpoint in there? Okay, so it is going to be at, well, we're going to add the x's, so we're going to say -2 plus 8 over 2, and add the y's, 1 plus 3 over 2. That is exactly the math that they do down there. See that? And as we work that down, -2 plus 8, we're going to get 6 over 2, which is going to be 3. And then we get 4 over 2, which is 2. So we get 3, 2. 1, 2, 3, and 2. There we go. Get a point right there. That's our midpoint. 3, 2. Okay. And would those coordinates be different if we use point A as our x2, y2? Hopefully, you're realizing they would not. It doesn't matter which side we come from to find our midpoint, because the midpoint doesn't change location. Midpoint is always in the same spot. Doesn't matter which spot we come from. So go ahead and practice that same math here. Pause and come back. Hopefully you found 1, 4. Okay. Now let's find a missing coordinate. What if they give you the midpoint and an endpoint? Can you find the other coordinate? So what if they give us that A is at 3 and 1/2 and the midpoint, or if that's the midpoint, and B is at 8, 3, can we find A? So what they do is they remind us of the equation, that the midpoint equals that equation, and then they fill in what we know, all those values. Okay, And then they break it into the individuals. They're going to break it into the x equation. That equals this. And this one equals this guy. So they're going to say 3 equals x1 plus 8 over 2. And 1/2 equals y1 plus 3 over 2. That's how they're going to deal with that. They're going to say there's 2 separate equations going on here, so let's pull them apart. Okay? It's kind of what's happening there. Okay. So as they work that down, you've got all that math in front of you, you find that the x1 equals -2 and the y1 equals -2, and then they're able to reproduce that in the coordinate plane. I love that on your notes, not on mine, it says plot those points to check your answer for reasonableness. Always check for reasonableness. Check, make sure that it looks right. Okay, now go ahead and practice number 4. Find the missing coordinates, okay? Here we go. And pause me. And hopefully you found 0, -6. Okay, let's go on to bisectors. Okay, bisectors. I want you guys to highlight this word because this word is a new word for us. This is a new geometry word. And it's not one that I had you fill in any word in the blank for, but here we go. What do I want you to highlight or underline? Let's see. The midpoint, it separates a segment into 2 congruent segments. Okay? Any segment, line, plane, or point that bisects a segment is called a segment bisector. Okay? So, bisect means half. It means perfectly cut in half. Okay? Cut in half. So, when something's been bisected, it doesn't mean it's just been cut. It means cut in half. It means a midpoint. It means perfectly cleaved into 2 perfectly halved things, okay? So, keep that in mind. Sorry, I just want to harp a lot on it apparently, but we'll keep coming back to it. So now we see this. It says, find missing measures. Find the measures of RT if T is the midpoint of RQ. As we see this, and as we've got a diagram here, I want to point out some things that we can do also. I think we've said some of this, but as we say that's a midpoint, that means that these 2 pieces are congruent. So I'm going to mark those as congruent with those congruent marks. They get these 2 dashes that say these are the same length, that RT and TQ are exactly the same size. So I'm going to mark them. That helps me remember. Same size. So this and this mean same size, or they mean congruent, okay? That's an indicator for me. All right. Now, if those are congruent, that means I can set them equal. That means that RT is equal to TQ. That's wonderful. So what I'm going to do with that then, and they're going to walk you through a proof here. Guys, this is a proof. And we're going to be doing more with proofs as we go. But what I want you to see with this is the math. But this is the reasoning over here. Okay? This is true. RT equals TQ is true because this is a midpoint, because T is a midpoint. And because RT is tx plus 3, we can substitute tx plus 3 in for it. And TQ, we could also substitute with 4x plus 5, or minus 5. And then we're going to do some subtraction. And then we're going to do some addition. And then we're going to do some division. Proof is just where we write out our reasoning, how we could do what we did on the math side. Okay? Okay. Now, we wanted to know how big RT was. Well, if we found out that X was 4 up here, we're going to come and plug it in for X, right? We're going to substitute. And then we're going to simplify. So we're still running that proof to solve for RT. And usually we would keep writing RT here. Okay. So go ahead and, the next question is there a way to find the length of TQ without calculating when you know the length of RT? So they're asking you, how big is TQ? If you know that RT is 11 units long, how big is TQ? Well, it's going to be 11 units because they are exactly the same length because it's a midpoint. T is a midpoint. Okay, so now this one says find the measure of RS, and I'm not asking you to write a proof. You can try and write one out if you want. That's totally, you're welcome to. Go for it. But I was just trying to show you a proof in there because you're going to end up doing some of those in ALEKS. You're going to be doing a lot of proofs in ALEKS, so it's good to kind of see them. Okay, right now I just want you to pause and solve for the measure of RS. Make sure you're solving for how big this length is. And hopefully you found that it was B. Okay. Now they're asking you to find the measure of AC if B is the midpoint of AC. So B is the midpoint, so we're going to mark those. And here's the trick. They want you to find the measure of AC. Make sure you're paying attention to what they're asking for. They want you to find the whole length there. So first thing we want to write down is that AB is equal to BC. So they're going to have you walk through all of those pieces, set them equal, solve down to find what X is, but they didn't ask us to solve for X, so we're going to keep going. What we're going to do with X, well, we can plug it into one of these up here. So that's what they're going to do. They're going to plug it, actually, they said, hey, what is AC? AC is equal to AB plus BC. So then they went ahead and added those together. That's how they chose to solve it. I probably would have solved for AB. You know, I would have plugged in 5 times 4 minus 3 and found that this was 17. And then this is 17, and then I would have done 17 plus 17. But there's so many ways to get to the same solution. It would have been fine either way. Okay? Okay. So go ahead and do the same thing here. Use what you know for practice 6. Pause and come back. Okay. Solution is 4.4. And if you struggled with anything, please throw your hands up, find a classmate, talk it out. Do not keep moving on without getting an answer.